Right, let's look at this question. Question 5.4.1. This is the February 2022 paper, and this is the moment of inertia question. So what type of graph came out in the February 2022 paper? It was a central hyperbola. Right, so a central hyperbola, how do you know that it's not an ellipse? So if there was a positive sign, then it will be an ellipse. Okay. The only difference is the sign. So be careful. If it's a minus sign, it's a central hyperbola. Right. So this is how it looks. It has two branches here. One cutting the x-axis, the other one cutting basically on the positive x-axis and negative x-axis. You've got x-intercepts. If the equation is in this form, it does not touch the y-axis. The shape is determined, it comes very close to these dotted lines, these asymptotes. The asymptotes are minus b over ax, it passes through the origin, and positive b over ax up there for the straight line with a positive gradient, and this one has a negative gradient. So let's sketch our graph. What do we have? We have x squared over 4 minus y squared over 9 is equal to 1. Now, what I would want to do first is get those asymptotes. Okay, we can get the x-intercepts, but the asymptotes are also important in order for you to determine the shape of the curve. Exact, whether this branch is wide or narrow. Also good for the N4 students. The N4 students, this was done in N4. So I mean, the N4 students need to know this properly, the central hyperbola. Alright, so let's see. What are we going to do? Let's rewrite this first in standard form. The standard equation here is x squared over a squared minus y squared over b squared is equal to 1. So we have x squared over 2 squared minus y squared over 3 squared is equal to 1. Okay, so now these asymptotes, minus b over ax plus b over ax, we can get our a and b straight from the question. If your question is in standard form, you got the number 1 on the right hand side, the coefficient on the top fraction must be a positive 1 there, a positive 1 there, then you know it's fine. Okay, so here you can clearly see your a and b. Let's just write that down. So my a is 2, b is 3. Right, so now the asymptotes. We got y is equal to plus b over ax. Basically plus or minus, you got one on the positive, one on the negative side. So this is equal to plus or minus, your b is 3 and your a is 2. So that's 3 over 2x. Right. Now, those are the asymptotes. That will be a guideline for us. So let's sketch this xy axis. Alright, so what I'm doing now is I'm just plotting a few points. I'm just marking off my xy axis. the straight line. Let's plot this graph. So we know, first of all, let's read the question. Do we need to sketch the full graph? No, we don't need to. How do we know? The area in the first quadrant. So we're only interested. Now if you look at the central hyperbola, the central hyperbola here exists in the first quadrant. Basically it exists on both sides. Okay. Now we are only interested in this side. Basically this upper half only. But let's just sketch the first and the fourth quadrant so you can see the full graph, the full half of it. Now, what do we know? Let's get this asymptote here. When x is equal to 0, y is equal to 0. When x is equal to 1, y is equal to 3 times 1 over 2, which is 3 over 2, which is 1, 5. So when x is equal to 1, 1, 2, 3, 4. When x is equal to 1, 5 could be somewhere around here. When x is equal to 2, if I put 2 here, 2 and 2 cancel, y is equal to 3. Now clear with that? So when x is equal to 2, y is equal to 3, which is somewhere around there. Okay. Then when x is equal to 3, y is equal to 3 times 3, which is 9 over 2, which is 4.5. So when x is equal to a 3, y is equal to 4.5. So there's 4.5, maybe somewhere around there. Right, so now why do we do this? So to get the asymptotes, so here is the positive straight, your asymptote with the positive gradient. Okay, so it's going to go there. Carries on, and here is your asymptote. Now, let's do this side too, one time. Why do I need to do a bit of this side? Because I need to draw that line down there so I can get this curve properly. Can you see the curve? So now, what do we know? When x is equal to minus 1, if I put a minus 1 here, I'm going to get minus 3 over 2 times a negative, which is a positive. Right, so this is going to be minus 1 and minus 1, 5 there. Then when x is equal to minus 2, you get positive 3, which is somewhere around here. Let's see, minus 2, positive 3, which is there. Now I have an idea of this line. So there's my asymptote. Alright, it only takes a few seconds to sketch that straight line, these two lines. Now, let's get the x-intercepts. We can read it straight from our standard form, or if you want to, you can work it out. Right, but clearly our x-intercepts here, you can see, if it's in the form x squared over a squared minus y squared over b squared is equal to 1, then your x-intercepts will be a positive a and a negative a. Okay. So basically it's going to be a positive 2 and negative 2. Or you can work it out. How are you going to work it out? Let y equal to 0, solve for x. Simple thing to do. Right, but now, what are the x-intercepts here? Minus 2 plus 2. So we know now, when we're sketching this curve, it's going to go up. You got your 2 there, it's going to go up there. It's going to come down this way here. And there's your curve on the right hand side. Can you see that? If I have to sketch on this side also, so I know it's going to go up there. It's going to come down, but it must not touch this dotted line. So now you know that's the shape of your hyperbola. Central hyperbola. Alright, so sketch the graph. The area in the first quadrant bounded by the graph, and x is equal to 4. So there's x equal to 4. X is equal to 4. If x is the subject of the formula, x is equal to a number, then that is a vertical line. Vertical, this way. If you had y equal to a number, then it will be a horizontal line. This is horizontal. Okay, so now let's do the x equal to 4. Right, so now this is not the required graph, it's more than the required graph that we have. We only are required to sketch in the first quadrant, so you can erase all this. Like you can erase it. You can erase everything in the bottom, you can erase everything on the left. But if you leave it, it's not a problem, as long as you understand the area that's being described is the area in the first quadrant. Because we have an area in the first quadrant and we have an area in the fourth quadrant. Okay. Now, we just want area in the first quadrant. So, calculate, okay, what is the first question? Use a perpendicular. Use a perpendicular, so this is clear. You do not have a choice. You have to draw a perpendicular representative rectangle to the x-axis. So, here's it. This is perpendicular to the x-axis. So, here's our differential element. Okay, so now we know that if we are using a perpendicular differential element with the base basically here is delta x, so you know we'll call the top y2, let's call the bottom y1. Remember, this is the x-axis, and we know now that the x-axis is a straight line. Okay, don't only look at it as an x-axis. The x-axis is a straight line. What is the equation of this straight line? It's y equal to 0. This is a horizontal line. Okay, also, sorry, this is the x-axis. Also, the y-axis is a vertical line. And the equation of this is x equals to 0. Okay, you must have an equation for everything. Now, what is required here? Calculate the moment of inertia of the solid obtained when the area described in question 5.4.1 rotates about the x-axis. So what do we know now? We know that delta x, this representative rectangle, is perpendicular to the x-axis. Now, if it is perpendicular to the x-axis, then we use the formula moment of inertia, which is I. The same symbol we use for second moment of area. The second moment of area is I, and the moment of inertia is also I. It's just that here we are rotating. With second moment of area, it's just an area. Here we're taking the area and rotating it about the x-axis or y-axis. So what is the formula for moment of inertia? Right, so now it's going to be mass times k squared. So mass times k squared. So now where k is equal to the radius divided by square root 2. This is called radius of gyration. Right, it's k is always the radius divided by square root 2. Okay, now radius. Why are we talking about radius? Because we are going to be rotating. Okay, we're going to be rotating around the x-axis. So when you rotate, volume is obtained. So radius is the distance from the center to any point on the circumference. Now what is mass? Mass is equal to density times volume. Now you see how volume comes about here. Okay, so mass is equal to density times volume. The symbol for density is P, volume is V. So M is equal to P times V. Right. Now we have volume. So we will be working out the volume. But which method will we be using? Now it all depends on whether your representative rectangle is perpendicular or parallel. Clearly it is perpendicular. So if it is perpendicular, we are using the disk method. Okay, if it is perpendicular, we are using the disk method. What is the disk method for volume? It's area of base times height, pi r squared h. Okay, pi r squared h. What's important is the radius. Yeah. How is your radius measured? Is it measured in terms of an x value or is it measured in terms of a y value? And you know how to make sure. That's which axis are we rotating about? We are rotating about the x-axis. That means the x-axis is now the center. So we're going around. That means you're going up and down. That means if this is the center, this is the end point. That means the distance from there to there is the radius. Can you see that? Now, the radius is in terms of y. If we are rotating around the y-axis, your radius will be in terms of x. Right, now, so I'm taking this as two graphs. Okay, I'm going top graph y2, bottom graph y1. So I'm going to go moment of inertia of the top graph minus moment of inertia of the bottom graph. Okay, so let me write down this formula first. So we got our mass, which is density times volume. This is our volume. Let's write down the volume, that volume delta Vx. Okay, volume. Now the disk method, you know that pi r squared h, your radius is in terms of y, so it's going to be pi r squared, which is y2 squared. The top graph here is y2, the top is y2, can you see that? Times delta x minus the bottom graph, which is pi y1 squared delta x. Okay, and we know that y1 is equal to 0 because on the x-axis y is equal to 0. So I'm going to simplify this here. So therefore, delta Vx is equal to just pi y2 squared delta x. Alright, so that is the formula for volume. Why do we need the volume formula? Because we need to substitute into the moment of inertia formula. Alright, so now your moment of inertia, delta I x. Where did I get this x from? You must be told axis of rotation or reference axis, x-axis. So now it's moment of inertia of the top graph minus moment of inertia of the bottom graph. However, what is the bottom graph here? What is the value of the y value here? 0. So the moment of inertia of the bottom graph is going to be just 0. Because 0 times anything will be 0 here. So basically it's just the y2 I'm dealing with. You are clear with that? So we're going to go mass, which is, mass is density times volume. So that's P times delta Vx, density times volume there, times K squared. Now you see where the K comes in. K is the radius divided by root 2. And what is the radius? The radius is y2. Okay, is that something different? It's the same radius, same graph. So it's going to be y2 over root 2 all squared. Let's do the substitution. So now I got A pi y2 squared. I'm copying down my volume formula, replacing it here, times delta x times you square this, that's going to be y2 squared over square root 2 squared is 2. So now if we just neaten this up, it's going to be p pi over 2, y squared times y squared will be y to the power 4. There's my dx here. Let's make this the total. Okay, let's put the integration sign in. Let's just leave it as it is, and then this is delta x, this is delta ix. Now we write down the total. That's going to be ix is equal to p pi over 2. Integrate. This is delta x. That means we are integrating with respect to x, so that becomes dx. X values, so let's write it as b and a, and that's y to the power 4. So this is the formula for moment of inertia using a perpendicular representative rectangle, and this is simplified just one graph only. If it was two graphs, then it will be the same thing here for this constant, but it will be maybe y2 to the power 4 minus y1 to the power 4. It will just be a subtraction, like how we do for volume. Remember that? This formula is given on the formula sheets, but we don't use the formula sheet for this here. You know, it's best to remember it this way. You need to check the diagram, check whether it's perpendicular, parallel, and it's best to understand it this way. You know, derive the formula. Because this is not the only formula. Right. There is the other method where you make it parallel, which we'll do next. Now it's the substitution. So what we're going to do now is we need to make y to the power 4 the subject of the formula. Where do we get y to the power 4 from? Where is the equation? What's the equation of this curve? The equation is x squared over 2 x squared over 4 minus y squared over 9 is equal to 1. Now your job is to take this equation, manipulate it, and then get it in the form y to the power 4 in terms of x. So you got a job to do here. You can see these questions are not that simple. Let me give you 2 minutes. Okay, so we need to manipulate this equation. What do we have? We have x squared over 4 minus y squared over 9 is equal to 1. So, what do we require? We just want y to the power 4. So, in order to get y to the power 4 here, what's here at the moment is y squared. So we need to get to y squared first, then from y squared we can square it, and then we'll get y to the power 4. So, task number 1 will be to make y squared the subject of the formula. But before you make y squared the subject, you have to make y squared over 9 the subject. Right, so this is going to be x squared over 4 minus 1 is equal to y squared over 9. Right, now what I'm going to do here is I'm going to multiply by 9. Well, let me find an LCD. Let me show you what's going to do. It's best to find an LCD here. Okay, so it's going to be x squared minus 4 all over 4 is equal to y squared over 9. So now all I have to do is multiply by 9 on both sides. So therefore it's going to be 9 times x squared minus 4 all divided by 4 is equal to y squared. Now, why is it best to find the LCD here? Instead of just multiplying by 9, if I multiply by 9, I'm going to have 9 over 4 minus 9, which is correct. There's nothing wrong with that. But why is it not the best way to do it? It's because now you need to square, and you don't want fractions inside here. Okay, it's best to have the fraction outside rather than inside the bracket. So what do I mean? I've got y squared is equal to 9 over 4 multiplied by x squared minus 4. You're clear with that? So now I can get my y to the power 4 by just squaring the left, squaring the right. So now I have y to the power 4 is equal to, now I can square this fraction easily. Can you see that? Square 9, you get 81, square 4, you get 16, and then this part here is now also squared, which is equal to 81 over 16, and then x squared, all squared, is equal to x to the power 4, middle term is 2 times term 1 times term 2, so minus 4x squared times 2 is minus 8x squared, and then minus 4 squared is going to give me a positive 16. Now we can replace it here. So therefore my ix there, I got p times pi over 2. I'm substituting my b and a now. You can see the area. Remember, this was the area. Starting at x is equal to 2, ending at x equal to 4. So that's going to be 2 here, 4 there. What is y to the power 4? Now y to the power 4 is 81 over 16, and that's x to the power 4 minus 8x squared plus 16 dx. So now you can see how I manipulated the equation and how we do not have any fractions to integrate, so it's much more simple. So now this is equal to, there's an 81 over 16, don't go and multiply it inside here. You're just going to make it worse for yourself. Leave it outside. Remember, when you're answering this question in the exam, this is question 5.4. You'll be running out of time. You need to be quick. So p pi over 2 times 81 over 16. So I've got 81 pi p, and 2 times 16 is 32. And now I can integrate everything here. So when I integrate x to the power 4, that will be 5 over 5. Integrate x, 8x squared, that will be 3 over 3. Integrate 16, 16x. Substituting 4 and 2. Work it out. Let's see what we get. So you must use your own calculator, and you must be fast on the calculator. when you're practicing. So if you're practicing, watching this here, you take out your own calculator, type it out, see how fast you are. Because you need to be doing it very fast in the final exam. Remember, N6 maths is not only about knowing your work, it's about how fast can you recall that information. Alright, so I substituted 4 first, and I got 98. Come just double check 1, 3 with a dot means recurring 3 minus substitute 2, I get 17.06 with recurring, that means 6, carry on. So that's 81 pi over 32p. Let's work this one out. So that's we get 81,06 recurring again. So you take this, multiply it by the fraction p, your answer will be in terms of p. Okay, so that's going to be times 81 pi all divided by 32, which is 644.654812.5p. That's the full answer that I'm getting on the calculator. Is that correct? Double check.
Yeah.
Double check on your calculator if it's correct. They only asked you for the moment of inertia. So that's going to be 644,655p. So this is in terms of the density. You could be asked to work out the moment of inertia in terms of the mass. Okay, then you have to do one more. It will be extra work for you. But you're lucky that they didn't ask you for that here in this exam. If they ask you to work out the moment of inertia in terms of the mass, then what would you have to do? You would have to remember that mass is equal to density times volume. So then you make P the subject of the formula. So therefore M divided by V is equal to P. And then you will replace P with M over V. But it's not just as simple as M over V. You have to work out V. So that means you need to go back here and work out the value of V. And then substitute it, and then you're done. Only if you ask to do that. It takes long to do. So only if you don't go and work it out unnecessarily in the exam. Only if you ask to do it, then you go and work it out in terms of the mass. So this was a perpendicular representative rectangle. So while we're on this, let's do the other method. The other method is a parallel. What happens if they ask you in this exam, draw a parallel representative element? Let's see. Alright, so we're dealing with the same question, same exam paper. February 2022. What was this question? 5.4. Right, so in the February 2022 exam, they asked you to use a perpendicular representative rectangle. What happens now if they ask you to use a parallel representative rectangle? So let's sketch that parallel representative rectangle. So we know the question is still rotate about the x-axis. We're not changing the question, we're just changing our method of working it out. Okay, so that is my differential element with a base of or thickness of delta y. Okay, so now we are rotating about the x-axis, but we are using delta y. So we need the y values in the, remember we're only dealing with the first quadrant. I just drew the whole thing for you, but this is all unnecessary in the bottom. So the area starts from this y value to that y value, the lowest point to the highest point here. So what is that lowest point? It is, what is the y value here? 0. Remember, that's why I said you must always label your axis. X-axis, y is equal to 0. So you know you are integrating from 0 all the way up to this y value here. What do we know about this y value? What do we know about this point? We know that x is equal to 4 because it's a vertical line. X is always equal to 4. So this is a point of intersection. So that means I can find the corresponding y value if I can substitute x is equal to 4 into an equation that has both